Physical Science 20, Chemical Reactions in the Mole. This is the lesson for the RM4 assignment, combustion reactions. Potassium chlorate warmed up to the melting point, a gummy, a shield. Potassium chlorate, KClO3, is an oxidizer. In grade 9, we learned that oxidizers can give oxygen to combustible materials. In this case, liquid potassium chlorate gives a combustible sugar in the gum a dose of highly concentrated oxygen. Combustion reactions. When an organic is in the presence of oxygen, it has the potential to burn. Here is a bottle of ethanol. Here is a blue jug full of air which contains oxygen. A lot of students say, why can't you do that twice? And this is why. Nothing happens. Why? If there is an adequate amount of oxygen available for a complete burn, the only products will be carbon dioxide and water vapor. I would guarantee there is still ethanol inside of the bottle. But since all the oxygen was used and had been turned to carbon dioxide and water, there is no oxygen to react with the ethanol that's in the bottle. Let's say the question has asked us to write the balanced reaction for the combustion of a stick of gum, which is composed of sucrose, C12H22O11. Since it is combustion, it's going to have to react with oxygen. And in a combustion reaction, there are always two products, that is carbon dioxide and water. Now we need to balance the equation, making sure that the elements on the left-hand side, which are our reactants, equals the number of elements on our product side, which is on the right-hand side. We said we always start by putting a 1 next to the most complex formula. Now I have to determine which element I want to balance first. I will not balance oxygen, for it is in multiple different spots, but I could start with the carbons, because carbon is only located in the sucrose and it's only located on the product side in the carbon dioxide. By putting a 1 with sucrose, that gave me 12 carbons. So that means I'm going to need 12 carbons in the carbon dioxide. So to get 12 carbons, I will have to have 12 carbon dioxides. Now I can balance out the hydrogens. By putting a 1 with the sucrose, that gave me 22 hydrogens. That means in the water, I will need 22 hydrogens. To get 22 hydrogens from water, I will need 11 water molecules. Now I have to balance the oxygens, as it is the only thing left. In the sucrose, when I placed a 1 with sucrose, that gave me 11 oxygens. Placing a 12 with carbon dioxide gave me 24 oxygens. And placing an 11 with the water gave me 11 oxygens. So on the product side, on the right-hand side, I have a total of 35 oxygen. On the left-hand side, the reactant side, I will need then 35 oxygens so that they balance out. I already have 11 with the sucrose, so that means I will need 24 coming from the oxygen. And in order to get 24 oxygen atoms from an oxygen molecule, I will need 12 oxygen molecules. Now everything is balanced. Write the balanced reaction for each of the following organic molecules when they are combusted. Example 1, turpentine. C10H16 is being combusted, so it needs to react with oxygen. And the products are always carbon dioxide and water. We always start balancing by putting a 1 next to the largest formula. In this case, that is turpentine. When we place a 1 with turpentine, that gives us 10 carbons. So if we have 10 carbons on the left side, we will need 10 carbons on the right side. And to get 10 carbons, we will place a 10 in front of carbon dioxide. Also, when I placed the 1 in front of the turpentine, that gave me 16 hydrogens. So if I have 16 hydrogens on the left-hand side, I will need 16 hydrogens on the right-hand side. In order to get 16 hydrogens, I will need 8 water molecules. Now on the right-hand side, I have a total of 28 oxygen. That's 20 oxygens in the carbon dioxide, 8 oxygens in the 8 water molecules. So if I have 28 total oxygen on the right-hand side, I will need a total of 28 oxygen on the left-hand side. And since turpentine does not have any oxygen, all 28 oxygen atoms must come from the oxygen molecules. In order to get 28 oxygens, I will need 14 O2s. Example 2. Write the combustion reaction for methanol. So to combust methanol, methanol must react with oxygen, producing carbon dioxide and water. I'll place the 1 in front of methanol, and that will give me 1 carbon. So I will need 1 carbon on the product side, so I will need 1 CO2. 1 methanol also gives me 4 hydrogen, so I will need 4 hydrogen on the product side. To get 4 hydrogen, I need 2 water molecules. The total amount of oxygen on the product side is now 4, 2 from the carbon dioxide, 2 from the 2 water molecules. So that means I need 4 oxygen on the left-hand side. Methanol has already given me 1, so I need 3 more oxygen atoms. Unfortunately, I cannot put a number in front of the O2 that will give me 3 oxygens. So I will have to begin again. So I place a 2 in front of the methanol. That will give me 2 carbons. And to get 2 carbons on the product side, I will need 2 carbon dioxide molecules. The 2 methanols give me 8 hydrogen. To get 8 hydrogen on the product side, I will need 4 water molecules. Now my total amount of oxygen on the product side equals 8. So that means I need 8 oxygen atoms on the left-hand side. Methanol has already provided 2 oxygen atoms, so I need 6 more coming from the O2. So I place a 3 in front of the O2, and my reaction is now balanced. And that brings us to the end of the RM4 lesson. Feel free to burn through the RM4 assignment.